So now we know what a function is, and we know the difference between linear and nonlinear functions, and so now our focus in this concept is to be able to graph a function. And so to do this, let's start with a function, and we're going to name it a of x is equal to 2x minus 3. Now I've got this table here, and I've got this graph on the side, and so what we need to do is, first of all, is this a line? Well, the answer is yes. It's x to the first is the biggest power that we've got in here. So it is indeed linear. So I need to pick some numbers for x, and I'm going to kind of do this in a pattern sort of way. I want to pick a few positive numbers, a few negative numbers, and 0 is always a good number to choose as well. So I'm going to build my table, and I'm just going to do this. I'm going to put negative 2 in for x, negative 1 in for x, 0, 1, and 2. Now, do I always use those 5 numbers? Well, no. And how many numbers do I need to make a graph of a function? Well, it just depends on the function. To make a linear function like this, all we need is 2 points, and it's always good to have a third one to check it. We're doing a little bit more than maybe what we would need to do just to show you what's going on here. And so here's the situation. This first column, this represents our domain, our x value, and we want to find a of x or the y value that goes with it. So what we're going to do is every time we see an x in the function, we're going to put in negative 2 to start with. So here we go. So this is going to give us 2 times negative 2 minus 3. Well, this simplifies to negative 4 minus 3, which is negative 7. Now, just to show you what's going on, that just gave us the point on the graph, negative 2, negative 7. Now we do it with negative 1. 2 times negative 1 minus 3. Well, that's negative 2 minus 3, which is negative 5. So I've got negative 2, or excuse me, not negative 2, but negative 1, negative 5. And I'll put in 0. 2 times 0 minus 3. Following order of operations and following the rule, I get negative 3, so it gives me the point 0, negative 3. I now put in 1. And hopefully you kind of see the pattern going on here, that each time I'm increasing the y value by 2. And this number out in front of x is what's driving that. So now I have the point 1, negative 1. And now I'll put in 2. And that's going to give me a positive 1, 2 comma 1. So now I have all these points, and I'm going to go over to the graph and plot them. So negative 2, negative 7, left 2. And all the way at the bottom at negative 7, I'm going to put a dot right there. Now I have negative 1, negative 5. 0, negative 3. 1, negative 1. You notice I'm making a nice line here. And 2 comma 1. So now I'm going to go and connect those points that I've got there. And I've got a nice line. Now, I'm going to put arrows on that line to show that that line goes forever in both directions as well. So I've just graphed a linear function. I knew it was linear because it's x to the first. So let's take a look at this b of x function, and let's graph this. Here's b of x is equal to 1/4 x plus 2. Now, it's going to make a line, but if I put in the numbers for the domain like I did last time, I'm going to get a lot of fractions. So let's try to avoid those. Now, one number I'm going to put in for sure is I'm going to put in 0 for x. Now, I need to think of a number I can take 1/4 of that comes out to be an integer. And since my denominator is 4, I'm actually going to use 4. And let me show you why. If I were to put in 0, first of all, that's 1/4 times 0 plus 2. Well, that just gives me 2. If I put in 4, that's 1/4 times 4. Well, 1/4 of 4 is 1, and 1 plus 2 is 3. I'm also going to put in another multiple of 4, namely 8, and show you what happens. Here's what happens on this is I basically have 1/4, and I'm going to write 8 as a fraction, 8 over 1. Now, I know 4 goes into 8 twice. I'll put a 1 down here. So when I add the 2, this really gives me 2 plus 2, which is 4. And you'll notice I've got a nice little pattern going with the numbers. So let me work backwards. Let me put in -4 and -8. And so I bet you can guess what happens. Yeah, it's 1 and 0 working backwards. In fact, 1/4 times -4 is -1 plus 2, which is 1. And 1/4 times -8, well, if a fourth of 8 is 2, a fourth of -8 is -2, and plus 2 is 0. So it worked out really nice. So let's go to my graph and try to plot this on here. I've got, first of all, -8, 0. 1, 2, 3. Now, on things like this where, you know what, it doesn't look like it's going to fit, what I can do is I can go ahead and scale my graph accordingly. And what I mean by that is this. I'm going to make each of these, I'm going to scale it just a little bit differently. I'm going to say that this is -8 out here. And this is 8 out here. Now, I'm still going to go with each of these. I'm going to say that, well, just to be consistent, 8, -8, I'm going to go ahead and say that up top here, this is also going to be 8 as well. And down below, this is going to be -8. So every box is going to represent 2 units. So that way I get a pretty good idea, and I can scale it however I want to, just as long as I've got some consistency in it. So let me change colors here so you can kind of see. I've got -8, 0. I've got -4, 1. Now that's going to be kind of in between. And then I've got 0, 2. I've got 4, 3. And again, I should be making a line, and 8, 4. And so I get this nice line going through. And I'll put the arrows on it again to show it goes forever in both directions. So now we're going to take a look at our final example. Here's c of x is equal to x squared minus 5. And this is not a linear function. I want to show you how you can graph one of these. It's really the same idea. And so there's no fractions involved. So I'm going to go back to my trusty -2, -1, 0, 1, and 2 for my domain. And I'm going to plug them in. And so this is going to be -2 squared minus 5. Well, -2 squared is 4, and 4 minus 5 is -1. Remember, when you square a negative, it becomes positive. So now I put -1 in, and -1 times itself is 1. 1 minus 5 is -4. I put in 0, square it, gives us -5, and now I'm going to put 1 in, and don't need the parentheses here because I don't have a negative sign to worry about. So 1 squared is 1, 1 minus 5 is -4, it looks familiar. And 2 squared minus 5 turns out to be 4 minus 5, which is -1. So notice I've got some y values that are the same, in fact. And so if I go and graph this on the coordinate plane here, I've got -2, -1. I'll start there. And I've got -1, -4. 0, -5, 1, -4, and 2, -1. Now the shape this makes is it's not a line, it's called a parabola, and you'll learn more about those later. But it's got some symmetry to it, and we can graph a nonlinear function much like a linear function. It's just not going to be a line. And so now you know the introductory parts of a function and the difference between linear and nonlinear and how to recognize it not only from a table, but we can now use a table to go ahead and graph both linear and nonlinear functions as well.